Maquinaria en Onda, un proyecto sonoro de Wequips.
Bienvenidos a nuestro podcast Maquinaria en Onda, un proyecto sonoro de Wequips para toda Latinoamérica. Yo soy Laura Castañedas, directora de marketing de Wequips, y en este nuevo episodio abordaremos el tema Innovación en Mejoramiento de Suelos, técnicas que transforman la construcción. Hoy tenemos el placer de hablar con un experto en la materia, quien compartirá su experiencia trabajando en proyectos globales, utilizando técnicas avanzadas como columnas y terraplenes geotextiles, y cómo estas soluciones juegan un papel crucial en el éxito de los proyectos más desafiantes. Sin más preámbulos, demos la bienvenida a Jeroen Dijkstra, especialista en mejoramiento de suelos de COFRA. Bienvenido, Jeroen.
Thanks, Laura. Happy to answer all your questions.
Nos complace tenerlo con nosotros hoy. Para empezar, nos gustaría saber qué lo llevó a especializarse en la mejora de suelos y a trabajar en proyectos tan diversos en el mundo.
That's a nice question. I didn't plan to be like a specialist in soil improvement. It just happened. When I was in university, I already found soft soils quite challenging. And then when I started working, I started during a period with very few vacancies. However, I came across COFRA and found a job there. And during my career, which is now already 20 years, I found actually soft soils and soil improvement and compaction with granular soils very challenging, because like no project is the same. Soils are like, they seem a bit like clay seems to be a bit the same everywhere, but still there are bits and pieces that are different. And like no project is similar, so you always keep the challenges. You always have the geology that's different environments of deposition. So I still find it a nice environment to work in. And like there's a lot of things that are to the art of the engineer, as they call it. And to come back to your second part, like the projects all over the world, I find it like a sort of addiction. Like it's nice to find different cultures, work with different environments, but also learn every country and the cultures of every country. And that makes the life also quite nice. Like you don't work a 9-to-5 job in the office, but see something from the world and meet a lot of different people all over the world. And also like you can bring your knowledge from our country, Netherlands, with very, very soft soils, to locations where they're not that familiar with the soft soils, and help everybody to get a better life.
¿Podrías explicarnos cómo funciona esta técnica y en qué tipos de proyectos se utiliza con mayor frecuencia, por favor?
Yeah, the ground improvement for soft soils are actually most of the time PVDs, like vertical drains or wick drains. They are like vertical strip drains, like there's a plastic core or a bio-based core or something else encapsulated with a filter, and these strips are installed into the ground. And this helps accelerate the consolidation of soft soils. Like a lot of difficult words like consolidation, soft soils, clays. Actually, what happens is like you can imagine the soil like a sponge, like you use in your shower, and if you compress it, the water will flow out. The same happens to a clay or a peat. Like if you compress that and you want to build something on it, so you load it with sand. Also, the clay wants to compress and change in volume. However, what happens actually is that the clay is very impermeable, and all the load is actually carried by the pore water that's inside, and it doesn't want to go. Like the same, like for example, if you drink from a paper pack, and you press it, like there's no volume change. Only when you put in your straw, you see that actually the juice comes out and you see the volume change happening. And the same what we actually do with the vertical drains. So we punch all the holes in the ground. With these vertical drains, we do that in a grid spacing of 1 to about 2 meters in a triangular spacing or a square spacing up to the depth of the full depth of the clay. And what we actually can do is make all the tiny holes, like the same as the paper pack, and make sure that the water flows towards these drains and can freely escape from the clay. And actually this shortens the adaptation time of the clay to a new loading from years to only a few months. So actually what we do is like make the area suitable for construction, so to meet its functional requirement of a couple of centimeters residual settlement in a year, or sometimes 10 centimeters in 30 years, or 20 centimeters in 30 years, to make it more economical, so you can construct anything on these soft soils. And this is how the consolidation techniques work. We have vertical drains, so it's like a passive system where just nature does its work, but we also have vacuum consolidation. And vacuum is actually the active pumping on these drains. Compare it to like drinking that same paper pack through a straw. So you suck out all the liquid, and you also see the volume change in the package because like you're creating with your mouth a vacuum, and that's actually more or less what we do with the vacuum pumps. And the vacuum pumps, like you can compare it to the same as vertical drains, but you can save 2.5 to 3 meters of surcharge load actually to compress that sponge I was talking about earlier. Hope this explains a bit the questions of the consolidation techniques.
¿Cómo funcionan estos terraplenes y en qué situaciones son especialmente útiles?
Yeah, compaction works actually quite different from consolidation, where actually you need to compress. And loading like a sandy or a granular soil doesn't work. It behaves elastic, so you have immediately adaptation to a new load. So if you just put something on sand, it will stand there, like same as your house. You can build a house on sandy soils or gravelly soils. However, to densify them, and what you see also if you vibrate these soils, they seem to densify. The same as, for example, you have a box of sugar and you tap on the side, you also see the volume change in the sugar. And the same happens with granular soils. So if you have like an area where you expect future vibrations by a machine that's on top, or even an earthquake, what can happen during the working or the functional life is that you have volume change, and you don't want to have that happen. If you would have like an earthquake, then suddenly there's a huge volume change if the sand is not dense enough. So that's why we densify sand during construction time, and we do that by inducing vibrations into the ground. Like all the compaction techniques we have like a roller compaction, we have big hammers like a CNC set where we actually bounce on the ground, and all these techniques we even have like a fiber float which goes down to the ground and then densifies the soil at depth. And these induce vibrations into the ground, and these vibrations densify the sand material. And we do that up to the specification we need to do. So it can recenter an earthquake, or it can increase like the resistance to densification of a heavy vibrating machine. So yeah, that's how we use that system to densify granular soils. So we have something for clays and peats, as in the previous question, to use that, to load it, and to make that settle less. And for the sand, you have different issues. So we increase the density of these.
¿Podrías compartirnos un proyecto destacado en el que el uso de columnas geotextiles y terraplenes con pilotes fue crucial para el éxito del proyecto?
Yes, we also have other techniques. So we discussed about like the consolidation of vertical drains. We have the compaction of granular soils. But sometimes you also want to load something on very soft soils and just build something very fast on it, and then you need to use elements. In that range, we have stone columns. So what we do is we bring gravel columns into the ground. We bring them down to a sand layer and cross, in that sense, like a compressible peat or clay layer. and that brings more stiffness to the ground and less settlement to produce the settlement. You can even construct structures on it. It also helps to prevent any liquefaction due to an earthquake. Liquefaction is that actually the strength of the material is lost during an earthquake event, and mainly in silty soils, so very fine particles. You see that actually still the earthquake has an effect of softening, so losing any strength, but the compaction systems don't work there. They will only work in the very granular soils. So you have a sort of zone where the compaction doesn't work. The PVDs in the very soft soils have a different effect and a different behavior. So we have the intermediate soils that need actually some other treatment methods, and these are the snow columns. So that's the system. And back in Holland, like where we're from, we also have some geosynthetic solutions with liners, etc., etc. However, in Colombia, we don't apply these because you have local installers that can do it far cheaper than we can do it if you have to fly in our experts from the Netherlands.
Muchas gracias, Jeroen, por compartir hoy tus valiosos conocimientos con nosotros. Ha sido un placer contar con tu presencia y aprender de tu experiencia en el mejoramiento de suelo. Agradecemos tu tiempo y esperamos ver cómo tu trabajo continúa impactando a la industria.
Thank you. I hope I explained it well, so you can also understand what we do and what we do with the ground to make it more safe for everybody, more stable, and to make it even like a more economical solution for construction, anything on the surface, especially in the challenging soft soils and loose granular soils. Thank you again, Laura, for the invitation, and hope to see you again in live in Colombia.
Ahora queremos compartir con ustedes cómo estas soluciones en mejoramiento de suelo de COFRA llegan a sus proyectos en Latinoamérica. Hoy nos encontramos con el ingeniero Jorge Castro, representante de ventas de Wequips para Latinoamérica. Bienvenido, Jorge.
Hola, Laura. Muchas gracias por la invitación y coméntame en qué te puedo colaborar.
Nos gustaría iniciar con la siguiente pregunta. ¿Qué impacto crees que tiene la introducción de las soluciones como las de COFRA en el desarrollo de los proyectos de infraestructura que se ven en Latinoamérica?
La solución, el de COFRA en el mejoramiento del suelo, va a tener un impacto positivo y significativo en los proyectos de infraestructura en Latinoamérica. Lo resumiría en 3 puntos clave. El primero es reducción en tiempos de consolidación, ya que tecnologías como las mechas drenantes permiten reducir los tiempos de años a meses, entregando obras cumpliendo con los estándares de cronograma y no aumentando los sobrecostos de estas obras. El segundo punto son otras soluciones que ayudan a mitigar fenómenos de liquefacción y reducir cantidades de materiales en obra, como las columnas encapsuladas, las cuales permiten aumentar la capacidad portante del suelo y mitigar los problemas de liquefacción en terrenos altamente sísmicos como los del cinturón del Pacífico a lo largo de Latinoamérica. Y una tercera solución que ofrece este tipo de tecnologías es la sostenibilidad y ayuda con el medio ambiente. Pues ofrece productos como biodegradables, para ejemplo las mechas drenantes, que ayudan en la sostenibilidad y medio ambiente a largo plazo en este tipo de obras.
Coméntanos sobre el uso de elementos como las columnas de geotextil que trae COFRA para América Latina, además de otros elementos como columnas de grava, terraplenes aplicados. ¿Qué nos pudieras decir sobre el tema?
Bueno, las columnas de grava son elementos perforados, los cuales se rellenan con grava y sirven para aumentar la capacidad portante en suelos muy blandos. Sin embargo, cuando estos suelos presentan resistencias muy pobres, menores a 15 kilopascales, estas columnas tienden a ensancharse y lo que hace asentamientos inmediatos, por lo cual COFRA presenta una solución que es encapsular este tipo de columnas con materiales granulares, lo cual minimiza o inhibe este problema y ayuda a ahorrar costos en la obra al utilizar materiales de la misma obra. De esto básicamente se trata las columnas encapsuladas de COFRA.
¿Y cómo crees que COFRA, con el apoyo de Wequips, puede apoyar a los ingenieros locales en la implementación efectiva de las soluciones? ¿Ofrecen capacitaciones o acompañamientos para la realización exitosa técnica de estos proyectos?
Claro que sí. COFRA y Wequips ofrecen, en colaboración con sus ingenieros y asesores, ayudas personalizadas y técnicas y comerciales en diferentes proyectos que requiera el cliente para este tipo de soluciones.
Muchas gracias, Jorge, por tu tiempo y la participación en nuestro podcast Maquinaria en Onda.
Gracias a ti, Laura, y gracias por este espacio que nos has permitido.
Muchas gracias también a todos nuestros oyentes en Maquinaria en Onda. Pueden seguirnos en las redes sociales de Wequips, TikTok, Instagram, Facebook y LinkedIn. En Wequips estamos comprometidos con proporcionar las mejores soluciones para el éxito de sus proyectos. Hasta el próximo episodio.